All right. Smart humidity control is already built in. 40 to 60%, that's your range. Guys, don't set these, don't let your homeowner set these to 40% because they will dehumidify all the time. I used to run into that with carriers, V&A and their Infinity series, and people would try, because it would go down to 46%. So naturally, they thought they could get to 46% in their house. And most houses, you can't get them that low.
We don't have a huge humidity issue.
No. No, your all's outdoor humidity in the wintertime, what I hear is the biggest part of the problem.
Yes. Yep, that's true.
The freezing fall.
Yep.
So it's available in cooling mode. It auto turns on when you turn the cooling mode. Any other mode deactivates it. All right, so let's talk about some troubleshooting here. All right. So let's talk about the data. Let's talk about data checking, where you can actually pull operational parameters on it while it's running. This data checking mode you can do anytime, whether the unit's running, off, just the fan running, it doesn't matter. So you can pull this information anytime. What you're going to do is you're going to take the handheld remote and you're going to point it at the display on the AHU. You're going to press and hold the power and the fan buttons for 7 seconds. When you do that, it's going to show 0 in the display. It'll show 0 in the display on the remote, and it'll show NA on the display, on the AHU display. Use the up or down buttons to query the current operating parameters. Up usually will cycle you all the way through. It'll go 1 through, I think, 20 something. Some of those aren't even used. There's a table in here. There's a table in here that describes it. So the row shows 0. Use the up and down buttons. That will display the different data. What you'll see is in the display, you'll see 1, 2, 3, 4, 5, 6 for the number of the data. On the display, it will show you the actual data and it will flash it. So if you're looking at T1 and it's, let's say T1 71 degrees, it'll show 71 degrees, go blank, 71 degrees, go blank, 71 degrees.
On the air handler.
On the air handler. On the remote display, it'll show 1. As in number 1. Here's the chart. 0, it'll show it. So if you get into 0, it'll either show an error code or it'll show NA. If you're not in an error code, it's going to show little small n, capital A. 1 is your T1 temperature. 2 is the indoor coil. 3 is the outdoor coil. 4 is the ambient temperature. 5 is temperature discharge of the compressor. 6 is your calculated frequency or the target frequency. 7 is the actual frequency. 8 and 9 are the running current and the AC voltage. Those will show you actual data. That used to show a hexadecimal number that had to be converted. It does show actual data now. So when you get to the voltage, if it's showing 220 volts, it will show 2 and then flash and then 20. Uh, 7-11 are reserved. PR is your actual indoor airflow. The number it shows you is multiplied by 10 to get the actual CFM. So if you're on that 2-ton and it shows an 88, you multiply that by 10 to get 880, and that's your actual CFM. LR, which is number 13, that's your EEV or EXV opening steps. That number is multiplied by 8. 14 and 15 14 is actually, that's your indoor fan speed in RPM. Your 15 is humidity, is the actual humidity sensors there. That is supposed to be there. That should be there. TT is set temperature after compensation. That is if somebody was to set temperature compensation on this machine to compensate for a difference in height. So like if this was up, if it was used, let's say it was using T1 at the actual T1 instead of the following on the wire wall control, you can actually change the compensation and make it read more what the room temperature is, and then that actually helps with comfort control. It's the same. It works the same as ductless temperature compensation does, where you're trying to compensate for stratified air layers. Yeah. Let's go back. I don't want to go that far in. 17, 18 are reserved. 19 is your outdoor bus DC voltage. 20 is target frequency calculated by the indoor. 21 and 22 are T2A and T2B.
Eric, I notice there's no target airflow and actual airflow. It's just airflow. So at what static pressure, total static pressure across that air handler's blower motor, will we start to see that our airflow will actually be less than what is calculated?
What is calculated?
So let's say, are we running like 1.5, 1.9 total, then we're no longer achieving higher
remember,
airflow?
so if the system is good out to 1 inch of water column, so it will deliver 100% of its rated or calculated or set airflow at 1 inch of water column. You get a slight loss once you go past 1 inch out to 1.2. If you go past 1.2, that airflow falls off the cliff.
Okay, that's more important for us to understand, is that there's gonna be a number at which we are no longer gonna be able to achieve
Right,
calculated airflow.
right. Exactly. And that number is once you get past 1.2.
Which is most systems.
Or 1, actually.
What? I mean, most systems, right? We
Yeah.
all understand high static, it's just,
Right.
since we don't have a data to say, hey, I'm trying to move 1200 and I'm only doing 9.
I don't know why they don't have that in there, but I think I think it's probably because they think it's meaningless, because we know what our airflow is out to 1 inch.
Yeah, well, I mean, anything beyond that, we know that, hey, we're gonna have to, I mean, we can pull doors, we can remove filter cabinets, we can do things to see that.
Right.
Is the feedback from that motor, is it a DC feedback that tells
It's
us?
gonna be a DC
So it's
feedback,
giving
yeah.
us actual RPMs converted to what that blower can do.
That's the data that you're gonna see in the display.
Perfect, thank you.
We just don't ever see that target airflow.
No, but we'll know, so I mean, if we.
No, it won't show you what the target airflow is, but it'll show you what the actual RPM of the motor is.
Oh,
So, yeah, so it'll tell us.
so the airflow that's in the engineering mode, that's the target?
Well, it's gonna be a calculate, that's your calculated airflow.
Right.
Based on the RPM feedback that it gets. Just like every other variable speed motor out there. Right.
So if I had a completely clogged filter,
Uh-huh.
it will tell me my less airflow, I pull that filter out, you'll see it immediately jump up.
Yeah.
It's a good tool for us in the dealer
Now,
to use.
okay, immediately, no.
But it'll get there, we'll
It'll
see it
get
change.
there.
It'll start to ramp.
It'll start to
It'll
where it is.
Yeah.
Okay,
Perfect.
engineering mode. So, engineering mode. I'm gonna start by saying, to get into engineering mode, you have to turn the system off. By the breaker on the AHU, and then turn it back on. The system has to be in standby mode. Or turned off at the remote or the thermos or the wired wall control. Once you turn the power back on, you have 60 seconds to get into engineering mode. You're gonna do the same thing that you did during parameter check. You're gonna press and hold the power button for 7 seconds. You're gonna use your up down arrows to select the channel you want to change. I believe there's 30 of them. To select the parameter or the channel of the parameter that you want to change. Okay? So if we're gonna change it, let's say we're gonna change 2, which is span stop on TS. Okay? What we would do is we use the up arrow till the display on the remote says 2. Okay? Then you press and hold the power button for 2 seconds. When you press and hold the power button for 2 seconds, this is going to show CH for channel number 2. That's going to show the actual data that it's set at. Use the up or down buttons to change the data on that. Then you're going to select OK. OK sends that parameter to the board. It should respond with this COCS, meaning command successful. Once you see COCS, back out of engineering mode, press and hold the fan and the power button for 2 seconds, which will back you out of engineering mode. Turn the power off to the air handler, turn it back on, and the parameter's been changed.
Can you do multiple channel changes on one power
I've
cycle?
heard 2 different stories. I've heard you can, and then I've heard you can't. I'm gonna tell you from what I understand of it, as long as you have a continuous button press within 30 seconds, I think you can change multiple parameters with one engineering mode, as long as you continue to press buttons within a 30-second span. If you fail to press a button within 30 seconds, it will back out of engineering mode automatically and your parameters will not be safe.
And realistically, using a communicating thermostat, communicating air handler setup, how often will we be in there outside of diagnostic and looking at setting? How often will we be in engineering?
Realistically, it's not gonna be very often.
Okay.
It's only gonna be, so that's gonna be case by case, installation by installation basis.
Seems
So
like a
that's
lot
one
of
of
the
those
dip
things-
switch settings are also the same thing. It's more of a default will work for most applications.
Most applications.
It's just if you have those parameters where you need to increase this, set up that, that's when you have to do it.
That's when you have to do
How
it.
often would you say, let's say out of 10 installs, how many of them do you feel would actually have to go into this engineering?
Well, I can tell you, we've done 7 or 8 field trials. We've done 7 or 8 field trials in Louisville, plus, 7 or 8 field trials in the Louisville area, and I've had to change one parameter.
So in
and
Kentucky,
I'll-
you've
and I'll
got all
check-
those and only
And
one.
I only changed that parameter because the China engineering team told me to.
Okay.
So if it hadn't been for them, I wouldn't have changed any parameters. So it's not very often that you're gonna have changing these parameters.
So a lot of these are gonna be, the remote's gonna be inside the air handler if in need of change.
Yes.
Otherwise, move on up.
If you don't hand this remote, to the homeowner, you do not hand this remote to the homeowner, the installer needs to take the batteries out of it, stick it in the air handler and
Nice
leave
little
it.
spot right next to the board for it to sit.
Or right next to the electric heater, depending on how big the electric heater is.
Yeah.
So yeah, leave it in the air handler. This is a very handy diagnostic tool.
I could see this being definitely something where you call into tech services saying, hey, my unit's doing this, that, and the other. Perfect, grab the remote, let's walk through this, let's start seeing what this thing is.
Because usually, and that's a lot of times, that's what we do when we get calls from our other distributors is, guys, you're gonna have to give us more information. Let's see a point checklist while it's doing this.
Yeah, please don't go out there without a remote or have the remote on site.
Right. Now, that being said, any remote will work, any piece of equipment.
So you can buy a replacement remote and have it at the shop.
Now, basic functions. So it will work, it will operate the basic functions, But it will also get you, you can also use any remote to get into parameter checking mode.
Okay.
So any remote will do it.
So for our units that we're gonna have on hand, they can have a replacement remote if needed.
Yeah, this is a remote, this is for a ductless unit.
Yeah.
If that unit was powered up, I can literally go over there, use this remote to pull the operating parameters off of it. That's the reason it's in my bag.
No, it's a great tool. I mean, it's just another tool for us to have.
Right. You must cycle the power on and back, or off and back on. So this is step by step on how to get in and out of engineering mode. The one thing this doesn't tell you is to back out of engineering mode. But my understanding is that you're really better off to back out of engineering mode and then turn your power back on.
So you can confirm that it did take.
Right. Well, you should have already seen the COCS at that. Once you see the COCS, that means the command was sent successfully. But you back out of engineering mode and then turn your power back off. And then that will store the command on board. So here's your these are your parameters that you're allowed to set up to 30, actually 29 and 30. 29, 30, 6, 7, 8, 9, and 10. There's nothing there to set. Those are reserved. There's nothing to change there. 1 is capacity setting. You really should never have to mess with that. Not 1, I'm sorry. 0 is a capacity setting. You really shouldn't have to mess with that. 1 is auto restart function. It comes out of the box with auto restart activated. I wouldn't mess with that. What auto restart is after a power outage, it restarts the same way it was set when the power went down. 2 is your fan stop on TS. There are several things you can do with it. You can stop the fan. You can make it run for, you can make it stop for 16 minutes and then run for 1 minute. But there are several things you can do with it. 3 is mode block, which means you can do cooling and heating, which is all modes. Heating only, which is heating and fan only. Cooling only, which is cooling, drying, and fan only. And you can do NU, which is cooling and heating without the auto mode. Guys, I'm gonna tell you, I don't know if I've told you how I feel about auto mode.
Yeah.
Don't get me wrong, I use it at my house when there's during the times when it's cold enough to use the heat in the morning. Personally, that's only because I'm married. And I want to stay married.
Yeah.
Okay, so if it was up to me, I would turn the heat on until it got down about 32 degrees outside in my house. But I can't do that because I'm married. So.
But that function is good for situations where, let's say it's in a server room, and we want to make sure that it cannot accidentally be put on heat.
Right. Yes, because that way you can set it to cooling only,
That's it.
and that's it, you're done. So 4 and 5 are the lowest and highest temperature setting. So the ST1 will go from 16 degrees C to, which is 60 degrees F, out to 86 degrees F, as far as the temperature range settings. All right, guys, if you're in these ones here, let's talk about 16 first. 16 is a 1 button reset. So if somebody has gone in there and jacked around with the parameters and you have no idea what the parameters were before they changed them, you're screwed, because I can't tell you, because there's no list of what they actually are coming out of the box. You can use the one button reset, that resets it back to the factory defaults.
There's no list of.
I have no idea what the factory defaults are.
All right.
I know one, which is, number two, which is probably, fan run, I think it's fan runs, it's actually comes out as, channel number two comes out, I think it's either 2 or 3, it runs it either the setting RPM or the lowest RPM, that's the only that's the only one I know. As far as the rest of them, and auto restarts out of the box. Most of these are set default, so like your lowest temperature setting is 16, your highest temperature setting is 30, that means 60 and 86 in Fahrenheit. Uh, 21 and 22 are heating and cooling compensation, temperature compensation. Remember what I was telling you about the temperature compensation for stratified layers? That's where you would set this. Fan volume selection. So that's 23 and 25. Those two are the ones we were talking about earlier, where you set your fan volume for either the cooling or the heating based on what your needs are, if you need to slow it down or you need to speed it up. That goes from, I believe, minus 40, subtracting 40, out to plus 20 is the range on it. It goes in 1-step increments. Each step adds or subtracts 20 CFM. So if you need to add 100, you're going to set that to plus 5. That's on 23, that's on number 23 and number 25. Uh, 27. All right, so here's where we were talking about enhanced defrosting, or the defrost. We had a question on that, correct?
Yep.
Okay. So we have an operation, we have a mode for enhanced defrosting. It can be either set through engineering mode on this remote or on the AHU, or there's a dip switch in the outdoor unit, SW1-4.
SW1-4.
In the outdoor, okay, is the enhanced defrost, the normal or enhanced defrost switch. If you flip that switch to on, what it does is it takes the defrost termination temperature and increases it to, I think, 25 degrees C.
Which is about,
That's 77,
what's it come out of the box for?
16 C,
Which is about
60.
So about 60. Oh, so we're coming out of the box with a defrost term of 60.
Right.
Wow.
We're gonna want.
But I mean, but some standard units only come out upper 40s.
Right, but in our areas here with our
You know, just turn it on.
inversions,
Just
we're
turn it
gonna
on
wanna
like
have
that.
it turned up.
Right. That will ensure you get a complete defrost.
Yeah.
Okay, so it does that, it increases that temperature. It actually reduced a time window on one of our defrost conditions from 120 minutes down to 70 minutes.
As far as when it looks to defrost.
As when it looks to defrost. It did that, and then there was a third change. I can't remember exactly what it was, but they've changed some of those parameters. Real quick, guys, one thing about defrost. With the ST1 and a unit that's sized correctly, you may never have problems with defrost unless you've got your freezing fog and stuff that you got to deal with, your freezing fog and stuff that you got to deal with. The one place I know that you could have defrost problems is if you're using a 24-volt thermostat and you do not set the cycles per hour correctly. And here's why. When we look for defrost, so our first condition hits at 29 minutes. That's our first condition that we're looking at. At that 29-minute mark, we're looking at the lowest temperature recorded of T3 between the minutes 7 and 12 of that run. Okay? If we don't hit that 12th minute of runtime, we lose T30 and we skip those two defrost conditions completely.
But that can happen even with a basic 24-volt thermostat set to the standard cycles per hour for
That's what I'm talking about.
But I mean,
That's exactly what I'm talking about.
even if you don't even change it.
Even if you don't change, well, I know, but this is what this is why I'm addressing this. So Echo Heat thermostats use minimum compressor runtime.
Yeah.
Set it as long as it'll go.
So most units, most 24-volt stats, the compressor cycle per hour is set at a factory of 3, which means we're gonna have approximately 20 minutes of runtime. And in lower demand times, that's obviously gonna shrink. So
If you hit that 10 minutes, if it only runs 10 minutes, you're not gonna get the 12th minute. So what I'm gonna tell you on like the Honeywell thermostats that come out of the box set at 3, 1 cycle per hour.
Please use the communicating thermostat.
Remember, we want this, yeah. Well, that's a good point, but remember, even with 24-volt mode, we want this thing to get down in into that low maintenance mode where it runs these long cycles. That's how we control, and that's how we can ensure better and more even comfort in the home, okay? If you set it at 3 cycles per hour, regardless of defrost issues, you're still gonna be, you reduce the amount of time that it runs down here. Because it also, the other thing when it starts, is it looks at the previous 5 cycles and where it started on the previous 5 cycles. So if it's always starting up here, that's where it's gonna start. If it starts reducing that level, it's gonna start down here.
But the only time.
That is important for everything.
So the only time we're gonna run into situations where we're gonna have to use a 24-volt thermostat is in a dual fuel application, correct?
no,
Oh, we can still use a communicating thermostat.
No, dual fuel, because the coil control box can use a wire controller and S1, S2 the outdoor.
the only time that would happen is if somebody put this on somebody else's unit, which is not an ARI match, and God bless, good luck, right?
I'm just thinking,
It's
of
not an AHR, so if they put it on an AHR match, good luck.
I'm thinking of someone using like a carrier infinity control that has a Y1, Y2 output from the board to a condenser and use that unit with a coil.
Yeah.
What that's going to do based off of what that controller is, even if you have comm wires going to the outdoor. It's a bad idea.
That's a bad idea. I mean, don't get me wrong, we're tied to carry with CMA partnership, but I'm still gonna tell you it's a bad idea.
Yeah, I know. Well, that's why I say it's because you know that there's gonna be.
Oh, yeah, there's gonna be some idiot out there that's gonna
Yeah.
try something really stupid and crazy, but yes. You know, realistically, the only time, even on dual fuel, realistically, the only time you're gonna need a 24-volt thermostat for that is if somebody is pairing it with a third-party unit.
Or somebody really likes their Nest.
That really likes their Nest thermostat or whatever.
I heard Nest thermostats accidentally fall off the wall, get stepped on.
Mine used to get hit with hammers.
Take hammers, just go flying around with flying.
Right on top.
You hear me say that and I'll deny it all day long. So that's enhanced
Yeah,
defrosting.
it's being recorded, so everyone knows.
Enhanced defrosting, you can either set it from engineering mode or you can set it with the dip switch out here.
Let's do the dip switch.
So dip switch is much simpler. Engineering mode is a pain in the ass, but it's a pain in the ass on purpose. Yeah, they don't want every Tom, Dick, and Harry getting in there and screwing with the parameters.
And we'll produce a little tech tip sheet that will say, these are our recommendations, and that will be on there.
Right. All right, refrigerant sensor detection. So there's your refrigerant sensor. That's what we use. It's a mix. Right now, it's a mix of Sensorion and Sensata. Right now, I think we're still using Sensorion, mostly because Sensorion actually has sensors and Sensata is right now is having trouble getting them. So what happens when a leak's detected? Here's what happens when a leak's detected. So I'm gonna focus on EHC1 and the FHCC. Because those are the errors that you will probably see out of this A2L. EHC1 is a leak detected. So when the indoor unit gets the sensor malfunction and it lasts for 10 seconds, that's FHCC there. Let's not focus on this one yet. EHC1, basically what happens if it gets an EHC1, it's a 3-strike rule. So what it does, and you'll see it on the next slide, but it basically when the sensor senses a level that is above 10% of the lower flammability limit, it goes into mitigation. There's a buzzer on the indoor unit that sounds. Louvers open, that's ductless. So there's some other things in there. FHCC is a sensor malfunction. And what triggers it is if the indoor unit can't talk to the sensor for at least 10 seconds. And if it lasts and it loses communication with the sensor and it lasts for 2.5 minutes, it will go into an FHCC. FHCC means that you either got a bad sensor or a bad connection somewhere. We've already eliminated the bad connection. And I'll show you that. That there's one connector in that box that is just a 2-wire connector. That is the FH, that's the A2L sensor. That is a waterproof, moisture-proof connection. Yeah, that's pretty much the two that you'll see. You'll probably see is the FHCC or the EHC1. EHC1 is a leak detected. FHCC is a sensor malfunction or a loss of communication with the sensor. So on the leak detection, if it goes above 10% of the lower flammability limit, we go into mitigation. Pressure stops, fan stops. Buzzer sounds for 5 minutes. The buzzer can be reset by pressing any button. That's if the homeowner doesn't want to listen to it for 5 minutes. Fan motor comes on at max speed and the error EHC1 is displayed. It monitors this for 5 minutes. If the lower flammability limit comes back down below 7%, the system will restart. If it doesn't, it starts the cycle over again. It'll do that 3 times. It'll do that cycle 3 times, and then it will lock out. And in order to restart it, the power has to be reset. That's how our leak detection cycle works. Now, from what I understand, FHCC, in the beginning, FHCCs would shut the unit down. They did in our Detroit CCHP field test units. I think they're trying to get away from that. They're trying to find a way to where FHCC, if it's a loss of communication with the sensor, they're trying to not shut the heat off. Does everybody understand that? Okay, So error codes. We'll start with these ones that are highlighted. These ones that are highlighted are all sensor errors. So our system will actually, if one sensor fails, our system will actually continue to run. It manufactures a fixed temperature for that failed sensor, and it will continue to run. If a second sensor fails, it'll stop. Now, here's what you'll see though. You'll see these, now it will still show the sensor error though. So if you see one of these sensor errors, don't always assume that the problem's with that particular sensor. So what it does, what the system does is it periodically polls all the sensors. And if you have a problem with the 5-volt DC bus and the bus goes down when it polls that sensor, it may not show that sensor as the problem. It may show another sensor as the problem. Or it may be another sensor it may be another sensor that's the problem. But when it polls the bus and it comes back up and it sees that particular sensor. So let's just say, for example, TP was the problem. And when it polled the sensors, the DC bus went down because of a shorted sensor. When the DC bus came back up, if it was seeing T3, that's the one that's going to show you. So don't always assume, because it says it's a T3 sensor, that it is the T3 sensor.
Always
So-
just check all your sensors.
Check all your sensors, check them all, because it could be any of them. One of the things I would do is disconnect the sensor from the board. I'll mount that particular sensor, just make sure it's good. And then check the 5-volt DC bus at the sensor with the sensor unplugged. You should be between 4.5 and 5.2 volts.
What are these good sensors supposed to own at?
Okay, so all of our sensors are 10K type 2 thermistors, with the exception of the TP sensor, which is compressor discharge. That one is a 55K.
Because it runs at a higher temp.
Because of the higher temps. It's actually 10K at a certain degree, and I can't remember it off the top of my head. But I know it's not 77 degrees. What I can tell you is it's really close and just about spot on. 55K at 77. So your 5-volt DC bus, also with that, the other thing to look out for is the 5-volt DC bus is fed by the 12-volt DC bus. So you could have a 12-volt DC bus problem that could show this sensor error. Your 12-volt DC bus is your EEVs, your stepper motors for the EEVs. Trying to think what else is in that 5-volt bus. I think that's it. Or in that 12-volt bus.
So the 12-volt feeds the 5-volt. The 12-volt bus actually will feed.
Yeah, the 12-volt bus feeds the 5-volt bus. So if you got a problem with the 12-volt bus, you may show up as a 5-volt bus DC, 5-volt bus problem. Okay. So if you're doing that, also check your EV stepper motors. They are 6-wire. Numbers off the top of my head. I know there's 2 commons on there. There's 2 commons on there, and then you'd have to look at the pin numbers in the manual, because I can't remember off the top of my head, but they should be somewhere around 45 to 50 ohms as far as the coils go.
Probably.
All right, ELO1. So we'll go over the most common ones here. ELO1, which is an indoor-outdoor communication. If you have a communication error of ELO1, the only way you're going to figure out which way it is, which one it is, where the problem actually lies, is using the Dr. Smart. Because that is RS-485 communication signal. You can't see it without an oscilloscope. And you might see some fluctuation, but it doesn't mean anything. So the only way to truly track down an ELO1 error on this system is using the Dr. Smart. Indoor fan speed out of control, basically that's just telling you that the fan either failed to reach 250 RPM or went outside of 800 and I think it's 880. All right, so the other one that I want to talk about on this, because a lot of these are going to be, some of these are going to be oddballs. You might see them once or twice, maybe once a year, once every 2 years. The other one that you want us to look at, the other one I want to look at is the PC00. That can also be a PC04. I know PC04. Yeah. So PC00 can be part of about 10 different faults. What PC00 is it's a problem with either the compressor or the inverter. So you have one of those faults that's in the PC40 range, anywhere PC40 to PC49, or a PC00. First thing I'm gonna tell you is to check the compressor. Now, there used to be a white dot on the front of the compressor when you pull the noise blanket off of it. There used to be a white dot. We used to put a white dot on the front of the compressor. They've actually since started putting the compressor tag on the front of the compressor instead of on the back. So the white field is a temperature sensitive material. So if it's turning yellow or it's turning brown, that means the motor has been overheating. The motor's probably demagnetized, the compressor's bad. Okay. If that checks okay, check your motor windings. Next step's gonna be check the motor windings. They should read just like a 3-phase motor. They should be within 1/10 of an ohm of each other.
What are we looking at, like 0.2, 0.3 ohms?
Sometimes it depends on the compressor. Sometimes it's a little over 1.
What's your lowest and highest range on your tonnages?
We don't. I have to look at it. I'd have to look at the book and it depends on the compressor because different compressors are going to have different resistance readings on them. So the actual range isn't important right now. Only thing I'm looking for is to see that all three are the same, or they're within that 1/10 of a degree of that 1/10 ohm deviance. Okay, so where it's at doesn't matter. I want to see if they're in range of one another. If that checks okay, check them to ground. Make sure you don't have any resistance to ground on them. If that checks okay, we're going to start looking at the inverter. We're going to go to PN, UV, and W. You're going to ohm with the power off and the compressor disconnected from the inverter. You're going to ohm between PN, UV, and W. They should all, so go P, N, UV, W, N, UV, W, all the way through. They should all be several mega ohms to open or infinity. If you get any reading that's like 2 mega ohms, I'm going to tell you the inverter's bad. Check it to ground. Same thing. Should be several mega ohms to infinity. If you don't find anything there on the inverter, what I want you to do is put P and N back, leave UV and W off the inverter. Restart the machine, or not restart, but repower the machine. Okay. If the current fault code, let's say it's a PC43, if the current fault code comes back and it comes back within 60 seconds, I'm going to tell you it's an inverter. If it changes, however, that means that the inverter passed its internal self-test and there's something wrong with the compressor. Most of the time, if you've got the compressor disconnected, what you'll see most likely is PC49, which is a compressor phase error. Those are those are the big ones that I want y'all to look out for, because those are the ones you'll see the most common. The rest of those, they're kind of oddball, they're kind of oddities, and you might see them once a year. That's your A2L errors again. That's all I got, guys. Thank you.
I want to touch briefly on dual fuel using coil outdoor unit.
Okay, so if you use our coil with the control on it, you do HAHV, and you can do HAHV and S1, S2. You can also do 24-volt thermostat, S1, S2. Now, as far as having dual fuel control, if you're using a 24-volt control, now as far as having any kind of lockout control where it switches, Stefan's the expert on this one because he's testing it in his house. As far as on a wireless wall control, I'm not sure that you have that ability. I think you don't have the ability to shut the system, to basically lock anything out or do an automatic switch up.
We do have some ability, yes. There was, it's on the S3 dip switch.
It's on the it'd be on the S3 dip switch.
Yep.
Yeah.
On the S3 dip switch, we do have the ability to say, hey, we want to lock out the compressor at this
At this
temperature
temperature.
and go to the
Yeah, go
gas.
straight to the gas. Yep. So like I said, Stefan's the expert on this because he's tested it in his house.
So we can use.
But as far as if you're using a 24-volt thermostat, your dual fuel control would come from your 24-volt thermostat.
Okay. But we can use that controller
Yeah,
and we
For
can
dual
actually
fuel, yeah.
wire the
Yeah.
HAHB
Mhm.
and then 24 volts to the
Absolutely.
mitigation board. Then the mitigation board has S1, S2 to the outdoor unit and 24 volt to our gas furnace.
yes,
And it will do everything as needed.
as needed for
And that will
mitigation, yes.
do, and that thermostat, we can do dual fuel switch over?
Yeah.
Okay.
Not with the thermostat itself, it's with the control.
With the
full
controller, correct.
Right.
Yes. And there's adjustments in the mitigation board based off of the switchover.
Yes.
Yes.
Yeah. So there's a board in the, with the gas furnace coil that is a board very similar to the board in the air
In
handler.
the H.
It has a couple of extra terminal strips for connection to the gas furnace,
Yes,
the 24-volt gas furnace. Other than that, it's very, very similar, and so we'll have very similar dip switch capabilities. And like we were talking about earlier with the S3 rotary dial, being able to set that
right,
rotary dial to an outdoor temperature to lock out the heat.
right,
We can also, we have the same rotary dial on the coils that we can set an outdoor changeover
right,
for the compressor.
Yeah.
So,
And we were recommending always using that outdoor unit with a matched coil.
yes. You can, like I said, you can do it third party. Like I said, you can do it third party, but there's no HRI rating for it. And the second thing is it's not gonna work near as efficiently as it does with our control box and the wired wall control.
Well, and with everything, we're in new refrigerants, so it really doesn't seem like it's gonna be that big an issue with people trying to do that because they're not adding on to an old coil that's out there because it's not rated for the new refrigerant.
It's not, no, and if they're gonna have to replace this, they gotta replace the indoor section anyway.
right, we can't use R454 outdoor with a 410A indoor or vice versa, right? So they have to be
So it should be
same
a
refrigerant inside as outside.
non-issue.
So it shouldn't be a big issue, no.
Yeah, that shouldn't be a big issue, no.
And everybody online, if you would go ahead and take scan that QR code and sign in, and if you guys could do it as well in here. sign in for Eric, so that way we can get a count of everybody we've had in here. Eric can prove that, he was here and did a training for us for his boss.
Yeah, I can get my star from my boss.
That's right.
For doing the
We'll
training.
go star sticker on his, report card.
Right.
No, in all seriousness, everybody, if you would, that's online, please sign in. And guys, if you could as well.
I did it mine.
Perfect. So we've got a question. Dr. Smart Tool is the recommended tool and Gensco sells them. Yes, that is correct. We did bring in the Dr. Smart tools. And they should be available online, on Gensco customer here in the next few minutes.
And Brandon had a question about, is there a diagram for dual fuel? Yes, we do have them. Reach out to your rep and we can actually email them to your team. It's a very nice, very well laid out wiring diagram that will help with dual fuel applications. That will be added to our tech tips that we will be making to make all the information that Eric has provided us today in a much easier format for your basic installations and setups. Any other questions from anybody in here or online that we can ask Eric while he is here? Is a Dr. Smart tool an actual tool or a program? It is an actual tool.
It's a tool, it's a diagnostic
Grab
tool.
it and show them up, put them up
Yeah.
front so they can see what the Dr. Smart tool is.
Yeah,
See it on Joe's code.
They probably won't here for a bit.
Yeah, we haven't put it on our Joe's code customer website just yet. So if you guys can see the tool that Eric is bringing out, it is a diagnostic tool that plugs into the equipment.
so this will plug into the equipment. This is the Dr. Smart. This is a diagnostic tool that will give you operating parameters and compressors, commanding compressor speeds. It will show you exactly what the system's doing. The first part of this, when you first power this up, this is the cable. You're gonna plug it into the 5-volt DC plug that's labeled test port on the machine. The first thing this thing does when you boot it up, especially if you're having a communication error, is try to establish communication with the indoor and the outdoor. So if it boots up and it can't communicate with one or the other, it's going to tell you which one is not communicating. But it is an actual tool that is a very handy tool for diagnostics and troubleshooting.
Awesome. Perfect. Thank you, Eric.
You're welcome.
Any other questions? Is it approved for manufactured homes or will it be in the future?
There's not an approval for manufactured homes, so that's gonna be based on what your inspector is going to require. Every state, every jurisdiction has different requirements. And Brandon, feel free to get in touch with me. And we can chat about that more, but that's really up to the local inspector on what they're going to require. This has not been specifically approved by HUD.
No.
That is something we're working on for the future.
Yes.
But right now that is, not been approved by HUD. Guys, any questions?
Will there need to be drain pan heaters for the outdoors
All of our units, that's a good question. All of our units come with a crankcase heater for the compressor and a base fan heater. All of them.
So yes, it does need one, but it's already there. Okay, that's good.
Yeah, you don't have to buy an extra.
Um, Toby, I see your question there. It depends on where you're at, so, drop me an email, if you would, please, with your contact info, and I'll reach out to you. Or drop it in the text here. I'll reach out to you and discuss that in a little detail with you. That way we make sure and get you the right info, because again, it depends on your area. For Washington specifically, we have found that Washington does not require the manufactured home approval rating. What they do require is that the system is an AHRI rating and that you have to document and verify airflow. And you have to have that document on site of the system for the inspector when they go to inspect it. They also have a checklist. All of the Washington equipment sales managers have that document, or all the equipment sales team has that document, so they can get out to you, get that out to you.
And Toby, also with the dual fuel systems, because the indoor coil has a mitigation board, we do have a very handy wiring diagram to show you for a proper setup and all the wiring for dual fuel applications. So, we can get that put together and get that out to you, as well as anybody else that would like it to be. Dual fuel and, our air handler obligated matches much easier. Any other questions, guys? Okay, there's no other questions. Thank you, Eric. We appreciate you.
You're welcome.
Everybody
My
that
pleasure.
joined in, we appreciate you guys, and we'll be getting some tips together to make this just that much smoother and that much more easier of an install for everybody.
Yeah, and like what David said, is we're gonna make some, just some quick one-page sheets that your installers can have with them for wiring and dip switch settings based on whatever wiring practice you're doing. Cause like Eric showed earlier, it does change a little bit whether you're doing a 24-volt stack or a fully communicating setup.
Yeah.
Okay, I think that's it.
Very good.
So.
Friday.
I think it might have showed a little bit.